Hi guys, in this lecture we will be starting with the concept of two-port networks. But before studying two-port networks, first we must get a grasp of the term port. What is meant by port? It is basically a pair of terminals from which a current can enter or leave a network. Okay? Like suppose if I tell you, let me take the case of a transformer. Okay? So current I1 will enter here, I2 will leave here. So these two terminals A and B, they will constitute a port. Let us say port 1, this is port 2, the terminals C and D. I1 will be traveling like this and I2 will be traveling like this. Okay. So net current entering or leaving a port is 0. I1 is entering from A, I1 is leaving from B. Because current needs a closed loop path for its flow, so the net current entering or leaving will be 0. So that is how a port is defined. It is a pair of terminals from which a current may enter or leave a network. Okay. Now, why these two-port networks are necessary for us? Basically, two-port networks is a way of modeling any system. Okay. In two-port networks, what we do is usually we model in terms of parameters. Okay. These parameters are independent of how the circuit works. That is, it is just a black box representation of a system in which you know the relationship between the parameters on one side and the parameters on the other side. Like voltage and current of one port will be related to the voltage and current of the other port, but you do not know internally how the system is constituted. Okay. But we will be able to determine the voltage and current of the system by the use of these parameters. That is the beauty of two-port parameter. Okay. So that means even if you are modeling a transmission line, a transformer, a BJT or FET, you do not care about the device or you do not care about the machine. You just care about what is the relationship between parameters on one side and the parameters on other side. Okay. So basically two-port networks are used to model BJT, op-amp, and in electrical it will be used to model transformer, transmission lines. Okay. So it can be used to model a wide variety of system provided that they have two ports, one for the input and other for the output. Okay. Like in transformer, primary is used as the input port, secondary is used as the output port. Like in case of BJT, base emitter junction is used as the input port, collector emitter junction is used as the output port in common emitter configuration. Now, similarly, one port networks can also be defined. In one port network, we just have one port, either for the that is used for the input. Okay, like here, if you see V1 I1, this is acting as one port, V2 I2 is the other port. Okay, so that is for one network and this is for the other network. So based on this, we define certain parameters. First one is your Z11, that is V1 by I1. It is known as driving point impedance. Okay, and since it is at the input port, it is known as driving point input impedance. Similarly, the reciprocal of this will be admittance. So it will be driving point input admittance. If we take the case of other network here, Z22 will be V2 by I2, that is driving point output impedance. What about Y22? That is I2 upon V2. It is driving point output admittance. So these parameters are usually defined for the case of one port network, as we do not have any transfer parameters. What is meant by transfer parameters? The parameters that relate to current on one side and voltage of the other side, or even current on one side to the current of the other side. That is, transfer parameters will relate one parameter on one side and the other parameter on the other side. These parameters that we have defined, driving point, impedance and admittance, they relate only the one-sided parameters, that is voltage and current on one side or the voltage and current on the other side. Okay, they do not interrelate the parameters on both sides of the network, but both sided parameters can only be defined for the two port network, because you at least need two ports to define the transfer parameters. Now when it comes to two port networks, two terms we commonly use: symmetrical and reciprocal. Now what is meant by symmetrical and reciprocal? Like a two port network will be represented something like this. This is my network. This is V1 and the current entering will be I1. Similarly, this is V2, current entering is I2. Now if you look from this side, that is from port 1, and you look from the other side, that is from port 2, if network is identical from both the sides, it is known as symmetrical. Means network identical from both ends. Okay, that is the condition for symmetrical network. How you can also explain it is, if the driving point impedance is same from both the sides, that is, I can say that if Z11 equal to Z22, then also I can say that the network is symmetrical. The next term is reciprocal. With respect to reciprocal, we have studied one network theorem that is known as reciprocity theorem. What was reciprocity theorem? Here we stated that if we interchange the terminals of response and excitation, then also the ratio of response to excitation remains the same. Okay. Interchange terminals, but yet response is same, or we can say response by excitation. So that is what is your reciprocal network. Now most practical networks should be reciprocal. Like in case of physical parameters, like suppose we are talking about transmission line. Then what is a transmission line? It is just a power carrier that is connected between the two nodes. It has the sole function of carrying the current from one end to the other end. But while connecting a transmission line, you do not know which end to connect to the source and which end to connect to the load. That is, even if you interchange the ends, it still has to carry the same current. That is why transmission line will be reciprocal always. Okay. So that is how in case of practical systems they must be reciprocal if they have symmetrical construction from the sending and the receiving end, or from the input and the output ports. Now let us understand some parameters that are defined for the case of two-port network. Okay. First, let me show you an example of symmetrical network. Suppose we take a T circuit like this. 1, 1, let us say 2. Now if you look from this side, 1 ohm is the nearest, then 2 ohm, then 1 ohm. Even if you look from this side, 1 ohm is the nearest, 2 ohm, then 1 ohm. So that is your symmetrical network. But now suppose I change this value to, let us say, 5 ohm. Then if you see from this side, 5 ohm is coming first, then 2, then 1. If you see from this side, 1, 2, then 5. So it is not symmetrical now. Okay. Now it will be asymmetrical. So that is how even by direct observation I can identify the symmetry in a network. Or you can understand in this way, if you divide this network symmetrically, then both the ends must be mirror images of each other. But here there is 1 ohm resistor, here it is 5 ohm, so these are not mirror images. Hence this is not a symmetrical network. Okay. So the first set of parameters that are defined for a two-port network is Z parameters. These are also known as open circuit parameters. That I'll tell you why these are known as open circuit parameters. Now, what does Z parameters do? They relate the voltages at both ends to the current at both ends. That is, it is a relation between the port voltages and the port currents. So how the relationship is defined? It is defined by means of superposition theorem. What we do is, we energize one port and then find out the voltage of both the ports, and then we energize other port and find out voltages again. The net voltage at any port will be equal to sum of the voltages due to I1 and I2. I1 is the current of port 1, I2 is the current of port 2. That is why it can be expressed as V1 is equal to Z11 I1, Z12 I2. This is the component of V1 due to I1, component of V1 due to I2. Similarly, V2, Z21 I1 plus Z22 I2. Component of V2 due to I1, component of V2 due to I2. In matrix form, we will express it as V1 V2 is equal to Z11, Z12, Z21, Z22, I1, I2. Okay. Usually the parameters of two-port network are used in matrix form because it is easier for us to operate in matrix form. There we can deal with a lot of parameters simultaneously. Now if you want to determine these parameters, like if I want to calculate Z11 from this equation, then I have to equate I2 equal to 0 so that the second term vanishes. So Z11 can be written as V1 by I1, V1 by I1 when I2 equal to 0. So what will you call Z11? Z11 will be called as open circuit input impedance. Why open circuit? Because when you are equating I2 equal to 0, you are essentially open circuiting the port number 2. Similarly, if you wish to calculate Z22, then we can calculate Z22 by means of second equation, which is V2 by I2 provided I1 equal to 0. So that will be called as open circuit output impedance. Here we are open circuiting the input port and then we are determining the output impedance. What about Z12? Z12 will be V1 by I2 provided I1 equal to 0. It will be called as open circuit transfer impedance. Open circuit transfer impedance at input. Okay. What about Z21? Z21 will be similarly V2 by I1 provided I2 equal to 0. That is your open circuit transfer impedance at output port. Okay. So that is why these are called as open circuit parameters, because if you wish to determine any parameter, then you have to equate one current to 0 or you have to make one port as open circuited. Out of two ports at any time, one port will be open to determine any parameter. Now as I told you, for the symmetry, what will be the condition? Driving point impedance from both ends must be same. That is Z11 equal to Z22 for symmetry. What about reciprocity? I told you the ratio of response to excitation must remain same. That is why Z12 should be equal to Z21 for reciprocity. Like even if you see here, Z12 is ratio of what? V1 by I2. That is, we have applied excitation I2 and we are obtaining the response V1. What is Z21? We have applied excitation at port 1 and observing the voltage at port 2. If both are the same, because the ratio of response to excitation must remain same, if we interchange the terminals or the ports, then only the network is reciprocal. So this is the condition for reciprocity, that Z12 should be equal to Z21. Similarly, we define Y parameters. Basically, these are the inverse of Z parameters. They will relate at the current at both the ports to the voltages at the ports. That is, I1 can be expressed as linear combination of V1 and V2. Similarly, I2 can also be expressed as linear combination of V1 and V2. So, again by superposition theorem, what we will do is, we will calculate I1 due to V1, then I1 due to V2, and we will add these components. Similarly for the case of I2. Now these are also known as short circuit parameters. As you might already have guessed it, like in the Z parameters, we were determining the parameters by open circuiting the ports. Here we will determine the parameters by short circuiting the ports. Now, here the equations that relate the current of one port to the voltage of the ports, I1 will be written as Y11 V1, Y12 V2. Similarly, I2 Y21 V1, Y22 V2. In matrix form, it can be written as I1, I2 will be equal to Y11, Y12, Y21, Y22, V1, V2. Okay. So that is how the Y parameters relate the current at both the ports to the voltages at the ports. Now to determine these parameters, Y11 can be written as I1 by V1 when V2 equal to 0. If you are equating any voltage equal to 0, that means you are short circuiting that port. So it will be known as short circuit input admittance. Similarly, Y22 will be I2 by V2 provided that V1 equal to 0. That is short circuit output admittance. Okay. These admittances will also be known as the driving point admittance. But when you want to define the relationship between current at one port and voltage at the other port, then you will define the transfer admittance. That is, if I write down Y12, it will be I1 by V2 provided V1 equal to 0. This will be transfer admittance short circuit transfer admittance at port 1. What about Y21? I2 by V1 provided V2 equal to 0. That is short circuit transfer admittance at port number 2. Okay. So that is how we define the impedance network, or we call it as impedance parameter and the admittance parameter. So what will be the condition for symmetry and reciprocity here? It will be similar to the Z parameters. What I'll say is y11 equal to y22 for the case of symmetry. Driving point admittance must be same, and y12 should be equal to y21 for reciprocity, because again we must keep the ratio of excitation to response or response to excitation same at both the terminals. And if you see, basically how the Z parameters were defined, V1 V2 is equal to Z parameters I1 I2. If we take the inverse of Z on both sides, Z inverse V1 V2 equal to I1 I2. That is, Y parameters are actually inverse of the Z parameters. Okay. So, to obtain the admittance parameter, you cannot directly take the reciprocal of the impedance parameters. Rather, you have to invert the matrix of the Z parameter. Do not think that y11 is equal to 1 upon z11. Rather, you have to take the inverse. The next set of parameters is known as H parameters or hybrid parameters. Now, the Z and Y parameters do not always exist. So, we have to define something called as hybrid parameter. Here, we are not relating the voltages to currents. Rather, voltage of one port will be expressed as function of the two parameters and current of the other port. Okay. That is, you choose voltage of one port and current of the other port. Like, V1 will be expressed as H11 I1, H12 V2, and I2 will be expressed as H21 I1 plus H22 V2. So, if you see voltage of port number 1 and current of port number 2, that is, it is mix of the impedance and the admittance parameter, hence it is known as hybrid parameters. In matrix form, it can be expressed as V1 I2 is equal to H11 H12 H21 H22 V2 I1 V2. Okay. Now, if you wish to find H11, H11 will be equal to V1 by I1, but when V2 equal to 0. So, it is driving point impedance under short circuit. So, it will be known as short circuit input impedance. What about H12? It is V1 by V2 provided I1 equal to 0. Now, usually how do you define the gain? We define the gain as the ratio of output to input, but it is the ratio of input upon output. So, it is your reverse voltage gain. So, it is your open circuit reverse voltage gain. What about H21? It is I2 by I1 when V2 equal to 0. So, that is your short circuit current gain, because it is the ratio of output current to the input current. Okay. Or even you can call it as short circuit forward current gain to distinguish it from the reverse current gain or reverse voltage gain. We can call it as forward. What about H22? It will be I2 by V2 provided I1 equal to 0. So, that is equal to open circuit output admittance, because equating I1 equal to 0, we are open circuiting the input port, and then we are calculating the admittance at the output port. So, it will be called as open circuit output admittance. Now, the conditions for symmetry and reciprocity for these parameters For symmetry, what will be the condition? The condition will be mod of h parameter must be equal to 1. That is mod h11, h12, h21, h22 must be equal to 1, due to which it will be h11, h22 minus h12, h21 will be equal to 1. Why is it the condition for symmetry? So that if you want to find out like here we are determining V1 I2, sorry, I1 V2. So that if you change the parameters to I1 V2 in terms of V1 I2, the inverse will not have any effect, because inverse is nothing but adjoint divided by the determinant. If determinant is 1, the magnitudes of the parameters will remain same. Okay. What about for reciprocity? For reciprocity, the condition is h12 is equal to minus h21. Okay. Because here what happens is we are assuming both the parameters of both the current set as inputs. Okay. That is I1 is also entering, I2 is also entering. But actually when it comes to a practical network, current must enter at one port and leave at the other port. That is why we have to introduce a negative sign in order to define the reciprocity. Reciprocity is nothing but if you interchange the response and the excitation, then their ratio must remain same. But as you can see here, current at both the terminals are entering. So you have to multiply one current by a minus sign in order to make that current leaving. Okay. Now as y parameters were defined as the inverse of z parameters, similarly g parameters are defined as inverse of h parameters. So these are also known as inverse hybrid parameters. So here what parameters we will relate? I1 and V2 will be related to V1 and I2. I1 will be G11 V1, G12 I2. V2 will be G21 V1, G22 I2. That means I1 V2 will be equal to G11 G12, G21 G22, V1 I2. Okay. Now if you wish to find G11, what you will do is I1 upon V1 given that I2 equal to 0. So it is your open circuit input admittance. Okay, we are open circuiting the port number 2 and determining the admittance at port 1. What about G12? It will be I1 by I2 provided V1 equal to 0. It is short circuit reverse current gain, because again the gain must be defined from output upon input, but here we are taking input current upon output current, hence the reverse gain. The next parameter will be G21, that is equal to, how G21 will be defined? V2 by V1 given that I2 equal to 0. So what it will be? It will be equal to open circuit forward voltage gain, because it is taking the voltage at the output port upon voltage at the input port. What about G22? It will be V2 upon I1, sorry, V2 upon I2 provided V1 equal to 0. That means short circuit output impedance. because by equating V1 equal to 0, we are short circuiting the port number 1 and determining the V2 by I2, that is the output impedance. Similar to hybrid parameters, what will be the condition for symmetry and reciprocity? For symmetry, we will say mod G equal to 1, that is G11 G22 minus G12 G21 must be equal to 1. And for reciprocity, G12 equal to minus G21. So remember, the conditions for symmetry and reciprocity remain the same in case of inverse parameter. That's why in case of Z and Y parameters, these conditions were same. In case of H and G parameters, again these conditions are same. Next we define the transmission parameters. Okay. Now these parameters are most important when we come to transmission lines or cables. Okay. Because usually these parameters are important when we cascade two systems. Cascade means when output of one system acts as the input of the other system. Then these parameters are especially helpful, and usually in case of transmission lines to achieve higher lengths or to achieve larger lengths of the line, because a transmission line is usually laid down for 200-300 km. That cannot be a single wire. It has to be a cascaded connection of multiple lines. In that case, we have to define the transmission parameters. How transmission parameters are defined? V1 equal to A, V2 minus B, I2. I1 equal to C V2 minus D, I2. That is, they are relating the parameters of port number 1 to the parameters of port number 2. Why minus sign is introduced here? You can either introduce a minus sign or you can express a network like this, A, B, C, D, then show I2 like this. Because when I drew the two-port network, I had drawn something like this. It was the network, I1 was like this and I2 was like this. But actually current must enter from one port and leave from the other. So if you assume I2 as leaving, then no need of this minus sign, you will use a plus sign. But if you are assuming I2 as entering, then we have to show this negative sign. This negative sign just signifies that the current is leaving from the port number 2. So these can be expressed in matrix form as V1 I1 equal to A, B, C, D, V2 and minus I2. Okay. Minus I2 means current leaving from port number 2. Now if you want to find A, it will be V1 by V2 given that I2 equal to 0. That is open circuit reverse voltage gain. Why reverse gain? Because it is input voltage by output voltage. Or it can also be said that open circuit voltage ratio, because it is the ratio of two voltages. Then B, it will be equal to V1 by minus I2 provided that V2 equal to 0. So it is your short circuit transfer impedance. Why transfer impedance? Because voltage of one port and current of the other port. Why short circuit? Because V2 is 0. What about the parameter C? C can be written as I1 by V2 given that minus I2 equal to 0. That is equal to open circuit transfer admittance. Okay, because we are open circuiting the port number 2 and then we are finding the transfer admittance, that is I1 by V2. What about D? I1 by minus I2 provided that V2 equal to 0. That is short circuit current ratio or short circuit reverse current gain. Okay. Now, the condition for symmetry and reciprocity for these parameters is, for symmetry, A is equal to D. For reciprocity, mod T equal to 1, that is mod of ABCD equal to 1, that is AD minus BC equal to 1. This is the condition for the case of reciprocal network. Next, we define the transfer ratio. Okay. Now, the transfer ratio, the transfer voltage ratio. First of all, transfer voltage ratio, it is defined as G12 equal to V1 by V2 and G21 will be equal to V2 by V1. What about transfer current ratio? In transfer current ratio, it is defined as alpha. Alpha 12 is I1 by I2. Alpha 21 is I2 by I1. Okay. That is your transfer ratios for the voltages and current. Okay. Now there are certain properties of the impedance parameters or impedance function and the transfer function which you must always remember. For impedance function, that too we are talking about driving point. That is V1 upon I1 or V2 by I2. Here it is your minimum phase function. What is minimum phase function? All poles and zeros are in left half plane. When all poles and zeros lie in the left half plane, it is known as minimum phase function. Similarly, for the case of transfer function, poles must lie in the left half plane because it must be stable. Zeros can be right half as well as left half. But for driving point impedance function, all poles as well as zeros must lie in the left half plane. Okay. Now, as I told you, we define the hybrid and the inverse hybrid parameters where Z and Y parameters cannot be defined. Such is the case for the case of transformer. Why the Z and the Y parameters cannot be defined? Because the primary and the secondary are not directly connected to each other. They are isolated from each other. So we cannot define the Z and the Y parameters. There is no direct relationship between V1 and I2 or V2 and I2. Okay, that is the voltages cannot be expressed as functions of I1 and I2. Okay. That is why usually the transformer is modeled in terms of transmission parameters instead of your Z and the Y parameters. So let us summarize what we covered in this lecture. I told you what is meant by two-port network. Then we saw the Z parameters. V1, V2 is equal to Z11, Z12, Z21, Z22, I1, I2. Here for symmetry we define Z11 equal to Z22. For reciprocity we define Z12 equal to Z21. Inverse of these parameters were the Y parameters. I1, I2 equal to Y11, Y12, Y21, Y22, V1, V2. Again for symmetry we defined Y11 equal to Y22. For reciprocity Y12 equal to Y21. Then we looked at hybrid parameters which related the voltage at one port, that is V1 with I2. V1 and I2 with respect to I1 and V2. The parameters were H11, H12, H21, H22. Here for symmetry what we studied? For symmetry it was the case that mod of these parameters must be 1. H11 sorry H11 H22 minus H21 H12 must be 1, and for reciprocity H12 is equal to minus H21. What about inverse hybrid parameters? They were defined like V1 I2 G11 G12 G21 G22. Now these parameters will be something like, condition will be same as hybrid parameters and G12 equal to minus G21. And the last we studied about the ABCD parameters or the transmission parameters, that is V1 I1 equal to ABCD V2 minus I2. So the condition for symmetry was A equal to D. For reciprocity, AD minus BC equal to 1. So these are the parameters that are defined for the two-port network. In the next lecture, what we'll do is, we will look at some problems that have been based on these parameters. Hi guys, in the last lecture we studied about the parameters of the two-port network. So we saw various kind of parameters like Z parameter, Y parameter, H parameter, G parameter and transmission parameter. So in this lecture what we'll do is, we will look at a few problems that are based on these parameters. So in the first problem it is asking us to express Y parameters in terms of Z parameters. Now as I told you, Y parameters and Z parameters are inverse of each other. That means Y11, Y12, Y21, Y22 is actually equal to Z11, Z12, Z21, Z22 inverse. Now when we want to take the inverse of a 2 cross 2 matrix, what we do is, we will divide it by the determinant, that is Z11 Z22 minus Z12 Z21. Then we interchange the diagonal elements and take negative of the off diagonal elements. Okay. Now Y11 will be equal to Z22 by delta Z. Delta Z is actually determinant of the Z parameter matrix. Y12 will be minus Z12 by delta Z. Y21, that is minus Z21 by delta Z. Y22 is Z11 by delta Z. So that is the relation between the Y parameters and the Z parameters. In the next problem, it is giving us the hybrid parameters and asking us to find the impedance parameter. Now what was the relationship of the hybrid parameters? V1 is equal to H11 I1 H12 V2. I2 is equal to H21 I1 plus H22 V2. What was the relationship of Z parameters? V1 is equal to Z11 I1 Z12 I2. V2 is equal to Z21 I1 Z22 I2. Now suppose first we have to find Z11, or let us better, first we will put these values in here. V1 is equal to minus I1 minus 2 V2 and I2 equal to 2 I1 plus V2. Now if you want to calculate Z11, then you have to calculate V1 by I1 when I2 equal to 0. Now if we keep I2 equal to 0 here, 2I1 will be equal to minus V2. Substitute it here. V1 equal to minus I1, then plus 4I1, that is 3I1. So what is V1 by I1? Sorry, 3I1, or directly I'll write 3 ohm. Okay, that is the value of Z11. Next we have to find, let us say, Z12. If you want to find Z12, it is equal to V1 by I2 given that I1 equal to 0. Now if we keep I1 equal to 0, then V1 will be equal to minus 2V2 and I2 will be equal to V2. So what is V1 by I2 then? It is minus 2 ohm. Okay. Next let us calculate Z21. It is V2 by I1 given that I2 equal to 0. If we keep I2 equal to 0, we will get 2I1 plus V2 equal to 0 or V2 equal to minus 2I1. Then what is the value of V2 by I1? It will be minus 2 ohm. Last is Z22. In Z22 we have to calculate V2 by I2 provided I1 equal to 0. If we keep I1 equal to 0, then I2 will be equal to V2. That is Z22 will be equal to 1 ohm. So these are the parameters or the Z parameters. If we express in matrix form, these are 3, minus 2, minus 2, 1. Okay. So that is your Z parameter matrix. Moving on to the next problem. It is asking us to find the transfer voltage ratio. So that means it is G12, that is V2 by V1. Okay. So here we have been given this network. So let us first identify the currents in each section. Here current is IA. Here current is 2IA. So current here will be 3IA. Now let us apply KVL here. If we are applying in this loop like this, it is V1 minus IA minus 3IA minus 2V1 minus V2 equal to 0. So V1 equal to 4IA plus 2V1 plus V2. Now V2 is the voltage across the resistance 1 ohm. So V2 is actually equal to 3IA into 1. Or we can say IA is equal to V2 by 3. So that will give us, if we substitute IA here, V1 minus 2V1 4 into V2 by 3 plus V2, that is minus V1 is equal to 7 V2 by 3. What is V2 by V1 then? It is minus 3 by 7. Okay. What is the significance of the negative sign? The negative sign indicates here that the output and the input voltage are out of phase with respect to each other. That is, there is a phase shift of 180 degrees between the input and the output voltage. In the next problem, it is asking us to find the transfer current ratio, that is I2 by I1. Again, let us identify the current in various sections. Here current is I2, here it is I1 by 2. So current here will be I2 plus I1 by 2. Here current is IA. So current here will be IA plus I2 plus I1 by 2. And here current is I1. So what is the current in 1 ohm resistor? Let me call as I1 ohm. I1 plus IA plus I2 plus I1 by 2. That is the current in the 1 ohm resistor. That is 3I1 by 2 plus IA plus I2. Now here we have to find the ratio of I2 by I1. So let us apply KVL. We will apply first of all KVL in this loop. Okay. So if we apply KVL here, then let me mark the voltages here. The voltages here will be, current here is like this downwards, so plus minus, current here is upwards, so plus minus. Okay, that is I 1 ohm into 1 plus 2 IA minus, sorry, minus 2 plus, it will be plus IA into 1. I 1 ohm was 3 by 2 I1 plus I2 plus IA plus 3 IA equal to 0. That is 3 I1 by 2 plus I2 equal to minus 4 IA. Okay, this is the first relation that we have got. Now apply KVL in this loop. In the second loop, like this. So plus 2 minus is minus IA into 1. Then minus 2 plus is, what is the current in 2 ohm resistor? It is I2 plus I1 by 2. What is the voltage in 1 ohm? It is plus I2. Now if you simplify this equation, it will be 2I1 plus 3I2 equal to IA. Now let us substitute IA in the first equation, which is equal to 2I1 plus 3I2. Now let us apply KVL in the loop number 2. Then what will be the voltages across different resistor? Since the current is flowing like this in the 2 ohm resistor, it will be minus plus. Current is going from bottom to up, minus plus. Now let us apply KVL. The voltage across 1 ohm will be minus IA into 1. What was the current in 2 ohm resistor? It was I2 plus I1 by 2, then plus I2. So we have applied KVL like this. Then it will be equal to IA equal to 3I2 plus I1. Now let us substitute this value in the first equation that we got. That is 3I2 plus I1. 3I1 by 2 plus I2 minus 4 3I2 plus I1. Okay. So we will get 3 by 2 I1, 3 by 2 plus 4 I1, and here we will get, it will be equal to minus 12 I2 minus I2. Okay. Now how much it will be? 11 I1, 11 by 2 I1 is equal to minus 13 I2. So what is I2 by I1? I2 by I1 is minus 11 by 26. So again this is a negative sign. This negative sign indicates I1 and I2 must be in opposite direction. That is I2 must be going downwards. Okay. And anyways, whenever we provide a current source, the current in the load must go downwards. In our next problem, it is asking us to find the input impedance of the given network with the transmission parameters given to us. Okay. So let me write down the relation between the transmission parameters. V1 is equal to 1 into V2 plus 2 I2, and I1 will be given to us as 1 V2 plus 3 I2. Since I2 is shown going outwards, That is why I am taking directly plus sign, otherwise I have to take minus I2. Remember this thing in the transmission parameters. If you take I2 as going into the network, you have to take minus I2. If it is coming out, you have to take plus I2. Now here, as you can see, the voltage in 10 ohm is V2 and the current is I2. So V2 can be written as 10 I2. That means V1 will be equal to 12 I2 and I1 will be equal to 13 I2. Then what is the input impedance? That is V1 by I1, that is equal to 12 by 13 ohm. That will be the input impedance of the given network. In our next problem, it is asking us to check the symmetry and the reciprocal properties. So here, let me show V1, I1. So you can make use of any parameters. I am using the transmission parameters here. Okay. So if we apply KVL here, V1 will be equal to V2 plus I2Z. Okay, because plus minus will be like this. By KCL, what will be the value of I1? I1 will be equal to I2 plus V1Y. But we need I1 in terms of I2 and V2. Substitute the value of V1 here. So that is equal to Y V2 plus I2 1 plus YZ. Okay. Now if we express it in matrix form, it will be 1 Z then Y 1 plus YZ. Now for symmetry, in transmission parameters we keep A equal to D. Here A is not equal to D, so it is not symmetric. What about reciprocal? For that we check the determinant, which is AD minus BC, which will come out to be 1 plus YZ minus YZ, which is equal to 1. Hence it is reciprocal. So it is reciprocal but asymmetric. Okay. So that is the property of this network. Moving on to the next problem, it is asking us to find the Z11. Now Z11 is actually equal to V1 by I1 given I2 equal to 0. That means we have to keep this port open. Okay. Here I2 must be 0. Now we will assume current I1 here. If current I1 is going here, then we have to apply KCL. Okay. So I will assume the voltage here as Vz. Here the voltage is V2. Here the voltage is V1. Okay. Now I will apply the nodal analysis. Apply KCL at this node. So Vz minus V1 by 5 plus Vz by 5 plus Vz minus V2 by 5. This is equal to 0. That is, if I multiply the entire equation by 5, what I will get? 3Vz equal to V1 plus V2. Okay. That is our first equation. Now apply KCL at this node. So what we will say? V2 minus Vz by 5 plus V2 minus 4V2 by 5. This must be 0. Now if I multiply the entire equation again by 5, what I will get? V2 plus V2 minus 4V2 equal to Vz. That is Vz equal to minus 2 V2. If we substitute this in the first equation, what I will get? Minus 6 V2 equal to V1 plus V2. So V1 equal to minus 7 V2. Okay. Now if you want to calculate the current I1, I1 is actually equal to V1 minus Vz by 5. So what about Z11? Then Z11 can be written as V1 over V1 minus Vz by 5. Now V1 is actually equal to minus 7 V2 and Vz is equal to minus 2 V2. Now V2 will get cancelled in the numerator and denominator. What we will get is minus 7 V2 by minus 5 V2 into 5, that is we will get 7 ohm. So Z11 will come out to be 7 ohm. Moving on to the next problem. It is saying if 1 ohm resistor is connected across port 1, find out the affected parameters and the new values of parameters Z. Okay, because it is given as Z parameters. Now here I will assume current as I1. So this current will be I2. Okay. Now V1 is equal to Z11 I1 plus Z12 I2. V2 will be equal to Z21 I1 plus Z22 I2. Now let us assume the voltage here as V1 dash. Now V1 dash is actually equal to V1 plus I1 into 1. That is V1 plus I1. And the current here will be same as I1. Now if you substitute V1 equation as V1 dash minus I1. If we substitute in this equation, V1 dash minus I1 is equal to Z11 I1, Z12 I2. Take this I1 term on the RHS. It will be 1 plus Z11 I1 plus Z12 I2. Okay. Now this current I1 is the input current, V1 dash is the input voltage. This equation will still remain same. That is only one parameter is affected. That is Z11 new is equal to 1 plus Z11. So if you connect any resistance in series with any port, it will be added to the driving point impedance at that port. So you can remember this as a direct result, so that whenever you see such kind of modification, you can add it to the input impedance or the driving point impedance. In the next problem, it is asking us to find the ratio V2 by V1 for the given network with the Y parameters. Okay. Now, since we are given the Y parameters of the network, here I will assume current as I1, here I will assume as I2. So, I1 is equal to 0.1 V1, 0.01 V2. I2 will be 0.01 V1 plus 0.1 V2. This is the equation based on the Y parameters. Now let us apply KVL here. 100 minus 25 I1 is equal to V1. If we apply KVL here, based on I2 the voltage will be like this. So V2 will be equal to minus 100 I2. So these are the four equations that will describe this network. Okay. Now if you see, if we substitute the I2 value in this equation, since we need to find V2 by V1. So I2 is minus V2 by 100 is equal to 0.01 V1 plus 0.1 V2. So 0.01 V1 is equal to minus 0.11 V2, because it is 0.1, this is 0.01. So what will be V2 by V1? It is minus 1 by 11. Again negative sign indicates that the voltage gain is negative, So if input voltage is positive, output will be negative. In this problem, it is asking us to find the admittance parameter or Y parameters for this network. So let us apply nodal analysis. As you know, this is the voltage V1 here. So voltage at node A is V1 and voltage at node B will be V2. So now let us apply KCL at node number A. So if you apply KCL at node A, then what is the current between A and B? Here the voltage will be, if this is V2, V2 minus 2V1. Okay, because this is the voltage drop of 2V1. So what is the current going here? Current going here will be V1 minus V2 minus 2V1 by 1. This is the outgoing current. This 2V2 is the incoming current. And what is the current here? Current here should be, here current is coming as I1 and here current is going as V1. So what is the current outgoing here? Current outgoing here is V1 minus I1. Okay, because V1 minus I1 is coming here, I1 is coming here, so current going here will be V1. Why V1? Because this is 1 ohm resistor, so voltage equal to current, which should be equal to incoming current, that is 2V2. So now if we see, it is equal to 3V1 minus V2 plus V1 minus I1 equal to 2V2. So 4V1 minus 3V2 equal to I1. So that is my first equation. Okay, so I have got the equation for I1, that is I have got Y11 and Y12. Now we need the equation for I2. Now let us apply KCL at node B. So the outgoing current will be V2 by 2, that is in this resistor. Okay, the outgoing current here will be V2 minus 2V1 minus V1 divided by 1 ohm, that is current like this. And what is the incoming current? It is I2. So I2 will be equal to V2 by 2 plus V2, that is 3 by 2 V2, then minus 3 V1. Okay, so this will be your I2. Is it fine? So now what are these parameters? 4 minus 3 minus 3 3 by 2. So this is your Y parameter matrix. Okay, so that means whenever you want to derive these parameters, just you have to keep in mind the equations which these parameters describe and then solve the network based on KCL and KVL and try to formulate such equations. So this is all from this lecture. In the next lecture, we will see some more problems based on two-port parameters. Hi guys, in the last lecture we saw some problems based on the parameters of two-port network. So in this lecture we'll continue from the same point and when we'll look at some of the more problems based on parameters of the two-port network. So if you see this problem, it is asking for the H parameters of the given network. Now what is the relationship for the H parameters? V1 is equal to H11 I1, H12 V2. I2 is equal to H21 I1 plus H22 V2. Now first we will determine the first equation, that is relationship between V1, I1 and V2. For that we will make use of KCL at node X. Now if you want to find out the voltage of node X, it is equal to V1 minus I1 RA. Then let us apply KCL at node number X. So what is the incoming current? Incoming is I1, outgoing is alpha I1 plus Vx by Rb, Vx minus V2 by Rc. Now, it means I1 into 1 minus alpha is equal to V1 minus I1 Ra upon Rb plus V1 minus I1 Ra minus V2 upon Rc. Let us take the LCM on the right hand side. The LCM will be Rb Rc. What is the coefficient of V1? Rb plus Rc. What about I1 Ra? Again Rb plus Rc. What about V2? It will be Rb. Now we will multiply Rb Rc on both the sides. What we will get? I1 Rb Rc 1 minus alpha plus I1 Ra Rb plus Rc plus V2 Rb is equal to V1 Rb plus Rc. To find out V1, we will divide both sides by Rb plus Rc. So it will be I1 Rb Rc over Rb plus Rc 1 minus alpha plus Ra plus V2 Rb over Rb plus Rc. That is actually equal to V1. So this term will be H11, this will be H12. Next we have to determine the relationship between I2, I1 and V1. Now for that you must make an observation here that if I2 is entering this port, I2 will be leaving this. If I1 is entering, I1 is leaving. By KCL, current in Rb will be I1 plus I2. Then the voltage of node X can be written as I1 plus I2 into Rb. Now let us apply KCL at this node. So in this node, the incoming current is alpha I1 and I2. What is the outgoing current? V2 minus Vx upon Rc. That is alpha I1 plus I2 V2 minus I1 plus I2 Rb divided by Rc. So if we collect the terms corresponding to each term, I1 will be alpha Rc plus Rb, I2 will be Rc plus Rb. That will be equal to V2. But we have to calculate I2. So what we will do is we will take I1 on the right hand side. So that will be I2 will be equal to minus alpha Rc plus Rb divided by Rb plus Rc into I1 plus V2 over Rb plus Rc. So this first term will be H21. The second term 1 upon Rb plus Rc will be H22. So that is how you can calculate the H parameters for this given network. Moving on to the next problem, it is asking us to find the transmission parameters. Transmission parameters relate the input and output parameters as V1 is equal to A V2 plus B minus I2. Why minus I2? Because it is showing as incoming current. I1 CV2 plus D minus I2. So this is the relation between the input and the output parameters. Now let us apply KVL at this input port. So V1 will be equal to I1 into 1.5 10 raised power 3 plus 10 raised power minus 3 V2. Okay. If we apply KVL at the output port, current here should be I2 minus 40 I1. That means V2 is equal to I2 minus 40 I1 into 40 kilo ohm. This is the relation between V2 and I2. Now if you solve these equations, that means if we want to find out A and B, then we need relationship between V1, V2 and I2. So we have to eliminate I1. So if you want to eliminate I1, then find the value of I1 from here. I1 is actually V1 minus 10 raised power minus 3 V2 divided by 1.5 into 10 raised power 3. This value can be substituted in the second equation. V2 is equal to I2 minus 40 10 raised power minus 3 V2 1.5 into 10 raised power 3 into 40 into 10 raised power 3. Okay. Now, if we simplify this equation, what we will get is, when we will simplify, V1 will come out to be minus 6.25 into 10 raised power minus 5, V2 minus 37.5 I2. So this is my parameter B, this is the parameter A. Okay. Now once we have gotten this equation, I need to find the I1 in terms of V2 and I2. So if we make use of the first equation that we got, which was V1 is equal to 1.5 into 10 raised power 3 I1 plus 10 raised power minus 3 V2. Then we can substitute the value of V1 here in terms of V2 and I2. That is minus 6.25 V2 minus 37.5 I2 is equal to 1.5 into 10 raised power 3 I1 plus 10 raised power minus 3 V2. So this way we can calculate I1 from here. First we will have to collect the coefficient of V2. The coefficient of V2 will be 10 raised power minus 3 approximately. So this equation will come out to be 6.25 into 10 raised power minus 7 V2 minus 25 into 10 raised power minus 3 I2. So that will be the parameter C and this parameter will be D. So that is how we can calculate the transmission parameters for this circuit. Okay. Since A parameter is coming out to be negative, it means voltage gain is negative, which implies that input and the output voltage are 180 degree out of phase. In the next problem, it is asking, in the circuit shown, find the value of load resistance for the maximum power transfer. Now these parameters are given as Y parameters, so it is not mentioned in the problem. Then we need to calculate maximum power transferred. We know for the maximum power transferred, RL should be equal to R Thevenin. That means first we need to convert this circuit into Thevenin's equivalent. Based on the parameters given, I can write I1 is equal to 5V1 plus 4V2 and I2 is equal to 4V1 plus 5V2. For Thevenin, we need to open circuit the load terminals, that is I2 must go to 0. So 4V1 plus 5 VOC. Why VOC? Because when I2 is kept 0, the voltage at the load end will be equal to the open circuit voltage. And what about I1? I1 will be 5V1 plus 4 VOC. Now what to do is, you need to substitute the value of V1 in terms of VOC. Or let us form another equation by KVL here. 100 is equal to I1 plus V1. We have three equations, we have three variables I1, V1 and VOC. So what we can do first of all is substitute VOC in terms of V1. So I1 will be equal to 5V1 minus 4 by 5 V1 into 4. that is 16 by 5. So it will become 9 by 5 V1. Since I1 is equal to 9 by 5 V1, we can say V1 is equal to 5 by 9 I1. Now I know V1 in terms of I1, I can substitute here. If we substitute in this equation, I1 is equal to how much? 9 by 5 V1. If we substitute here, 9 by 5 plus 1 V1 is equal to 100. So V1 is equal to 100 into 5 by 14. Okay, that is equal to 250 by 7 volt. Now we know that what was the equation between V1 and VOC? It was, we kept I2 equal to 0, which meant 4 V1 plus 5 VOC equal to 0. Okay, so VOC is minus 4 by 5 V1, that is minus 4 by 5 into 250 by 7, that is equal to minus 200 by 7. So this is my Thevenin voltage. To find out the Thevenin resistance, we need to use the short circuit current. If you want to find out short circuit current, then you will equate V2 equal to 0. Now the equation were I1 is equal to how much? I1 was equal to 5 V1, then V2 equal to 0, I2 will be equal to 4 V1, and I2 will be equal to minus ISC. Why minus ISC? Because under short circuit the current must go into the short circuit. So I2 will be kept as minus ISC as their directions are opposite. That means ISC is equal to minus 4 V1. And again we can write the same equation. 100 minus I1 is equal to V1. That is 100 minus 5 V1 equal to V1. That is V1 equal to 100 by 6. So what is ISC? Minus 400 by 6 ampere. R Thevenin can be written as VOC by ISC, that is minus 200 by 7 into minus 6 by 400. So that is equal to 3 by 7 ohm. So load resistance must be equal to 3 by 7 ohm in order for the maximum power transfer. And what is the maximum power transfer? Maximum power transfer is actually VOC square by 4RL. That is 200 by 7 whole square divided by 4 into load resistance, that is 3 by 7. This comes out to be 476.19 watt. So that will be the maximum power that can be transferred to the load, and for that load resistance must be equal to 3 by 7 ohms. In the next problem, it is asking for the parameter H21 for the given network. Now we know H21 will be equal to I2 by V1, I2 by I1 when V2 is 0. Okay, because I2 is actually H21 I1 plus H22 V2. If you want to keep V2 equal to 0, we will short circuit this. If we short circuit this, current here is I1. Current here will go I1 by 2. Here also I1 by 2. That means I2 is equal to minus I1 by 2, because their direction is opposite. Now that means I2 by I1 will be equal to minus half. That is minus 0.5. So that is the parameter H21 for the given network. In the next problem, it is asking the admittance parameter y12. Now, in terms of y parameters, what is the equation? I1 is equal to y11 v1 plus y12 v2. So, what is actually y12? I1 by v2 when v1 equal to 0. If you want to make I1 by v2 when v1 equal to 0, we will short circuit this terminal. This resistance also gets shorted. So what is the network left with us? (20), 10, and here we have E2. So what is the current going here? Let me call it as I. I is equal to E2 by 20. But as you can see, I1 and this I are in opposite direction. So I can say I1 equal to minus I. That is I1 equal to minus E2 by 20. Then what is equal to I1 by E2? Minus 1 by 20, or we can say minus 0.05 mho or 0.05 Siemens. In the next problem, it is asking for the open circuit impedance matrix. That is, it is asking for the Z parameters of the network. To determine Z parameters, first we will have to find the current in each branch. I2 is the current here, 3I1 is here. So current here will be I2 ohm will be I2 minus 3I1. Then what is the current in 1 ohm resistor? It is I2 minus 3I1 plus I1, that is I2 minus 2I1. As we know, the voltage across 1 ohm resistor is V1. So V1 will be equal to I2 minus 2I1. From here I get the Z11 and Z12. Then we have to find V2. Apply KVL in this loop. V2 is equal to I2 minus 3I1 multiplied by 2 ohm plus I2 minus 2I1 multiplied by 1 ohm. So V2 will be equal to 3I2 minus 8I1. So what are the parameters? V1, V2, I1, I2. In V1 equation, what is the coefficient of I1? It is minus 2. For I2, 1. In V2 equation, coefficient of I1, minus 8. For I2, it is 3. So these are the open circuit impedance matrix for the two-port network. In next problem, it is asking for specific parameters of the Z matrix, that is Z11 and Z21. Z11 and Z21 we have to determine. Now, for Z11, what we will write? V1 by I1 when I2 equal to 0. So if I2 is 0, current I1 is coming here. Current I1 will go like this. So if we apply KVL, E1 is equal to 2I1 plus 4I1 minus 10 E1. That is 11 E1 is equal to 6I1. So E1 by I1 will be 6 by 11 ohm. For Z21, what we will do? V2 by I1 when I2 equal to 0. Now V2 is the voltage across this combination. So V2 is actually equal to 4I1 minus 10 E1. Okay. Remember this thing, here also I2 is 0. So I can consider the I1 current going into this combination. 4 into I1. E1 can be written as 10 E1. 10 into 6 by 11 I1. Okay. So it is 44 minus 60, that is minus 16 by 11 I1. So what is V2 by I1? It is minus 16 by 11 ohm. So that is your next parameter Z21. In the next problem, it is asking for the hybrid parameters for the circuit shown. What is the relationship for hybrid parameters? V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. To determine the hybrid parameters, first of all, we need relationship between V1, I1 and V2. Now if we say the voltage here is V2, so by KVL what is V1? V1 is V2 plus 10 I1, because plus minus will be like this, or V1 is equal to 10 I1 plus V2. So this is how we can formulate our first equation. Then next we need to find out I2. By KCL I can say I1 plus V2 by 20. Sorry, I1 plus I2 should be equal to V2 by 20. I1 is incoming at this node, I2 is also incoming, outgoing will be V2 by 20. That is I2 is equal to minus I1 0 minus 0 plus 0.05 V2. So what is the matrix? V1 I2 is equal to then 10 I1 1 V2 minus 1 I1 0.05 V2. So here I1 V2. Okay. So these are the parameters for the two-port network, that is your hybrid parameters. In the next problem it is saying a two-port network is shown below, which is excited by external DC sources. That is 6 volt and 1.5 volt are my external DC sources. Now the voltages and currents are measured with voltmeters and ammeters. Now the switch conditions for which we have been given different readings. Now when S1 is open, assuming ideal voltmeter means current in voltmeter is 0. So if this port current is I1, then ammeter A1 measures I1. If this port current is I2, ammeter A2 measures I2. Okay. So that means reading of A1 is equal to I1. So if it is saying A1 equal to 0, that means I1 equal to 0. So what is the relationship between the Z parameters? V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Now if it is I1 equal to 0, V1 will be equal to Z12 I2. So what is Z12? It is V1 by I2. V1 will be measured by voltmeter V1, I2 will be measured by A2. That is 4.5 ohm. That is V1 by I2. From the second equation I can say V2 equal to Z22 I2. That means what is Z22? V2 by I2. 1.5 by 1, that is 1.5 ohm. In the next case it is saying that reading of ammeter 2 is 0. If reading of ammeter 2 is 0, that means I2 is 0. If I2 is 0, V1 will be equal to Z11 I1. So what is Z11? Reading of V1 by reading of I1, that is 6 by 4, that is 1.5 ohm. And what is V2? Z21 I1, which means Z21 is reading V2 by I1 6 by 4, that is 1.5 ohm. So what is the matrix? The matrix will come out to be 1.5, 4.5, 1.5, then 1.5. That is your Z matrix for this network. In the next part of the same problem, it is asking the H parameters of this network. Now for that, we must find a relation between the Z and the H parameters. How the H parameters are related? V1 is equal to H11 I1 plus H12 V2. I2 will be H21 I1 plus H22 V2. What about Z? V11 is equal to Z11 I1 Z12 I2. Then V2 equal to Z21 I1 plus Z22 I2. Now first we have to calculate H11, which is equal to V1 by I1 when V2 is 0. If you equate V2 to 0 in this equation, 0 is equal to Z21 I1 plus Z22 I2. That is minus Z21 I1 equal to Z22 I2. Okay. If we substitute this relation in the first equation, substitute I2 in terms of I1, V1 will be equal to Z11 minus Z21 by Z22 into Z12 I1. So what is H11? It is Z11 minus Z21 Z12 by Z22. If we calculate this term, Z11 was coming out to be 1.5 minus 4.5 into 1.5 by 1.5. That is equal to minus 3. So H11 comes out to be minus 3. Similarly, since we have kept V2 equal to 0, I2 will be H21 I1. That is I2 is equal to H21 I1. And from this equation I can say I2 is equal to minus Z21 by Z22 I1. So H21 is minus Z21 by Z22. That is minus 1.5 by 1.5, that is minus 1. Okay. So these are the two parameters of the H matrix or the hybrid parameters. For the next two parameters, now we have got H11 and H21. We have to keep I1 equal to 0. If you keep I1 equal to 0, then the first equation will be V1 is equal to Z12 I2. And if you compare it to this equation, it will be equal to H12 V2. Okay. And from this equation, V2 will be Z22 I2. Now if you take V1 by V2, it is equal to Z12 by Z22. And from this equation, V1 is equal to H12 V2, it is equal to H12. So Z12 by Z22 is 4.5 by 1.5, that is 3. So that is how we will get H12. What about the next parameter? From the next equation, we can determine H22. H22 will be equal to I2 by V2 when I1 equal to 0. If I1 is 0, then the second equation will be V2 is equal to Z22 I2. So what is I2 by V2? 1 by Z22. So H22 is equal to 1 by Z22. That is 1 by 1.5, which is equal to 0.67. So what are the parameters? First one was minus 3. Then second one we got as 3. Then this we got as minus 1. This is 0.67. So this will be your hybrid parameter matrix. So usually in GATE examination, if you are being asked the entire matrix, that may be for the 2-mark question. If you are being asked a specific parameter out of all the parameters, then it will be for the 1-mark type of problems. Okay. So such kind of questions can be framed in GATE exam. In the next lecture, we will continue our study of the 2-port parameters, and we will see the connection of different networks and how the parameters will change when two networks are connected to each other. Hi guys, up to now we have studied about the parameters of the 2-port network. So we have seen 5 type of parameters, out of which first one was Z parameters. In Z parameters, we were relating the quantities V1 and V2 to I1 and I2. Then we looked at Y parameters, which were inverse of Z parameters. these parameters related I1 and I2 to V1 and V2. Then we looked at hybrid parameters which were used wherever you cannot use Y and the Z parameters. These related V1, I2 to I1 and V2. Similar to Y parameters, there were inverse H parameters known as inverse hybrid parameters represented as G. They related I1 V2 to V1 I2. And the last that we saw were transmission parameters, also known as ABCD parameters, which are mostly used in transmission lines. They related V1 I1 to V2 and I2. In this lecture, we will study more about these parameters, and then we will study the interconversion of these parameters, that is, how to convert one parameter into the other. So first let us see the T equivalent of Z parameters. So if you want to determine the T equivalent, then let us look at this T circuit. So to determine the Z parameters, we need relation between V1, V2 and I1, I2. To determine that relation, we have to apply KVL, but first we have to find current in ZB. By KCL, current in ZB is I1 plus I2. So now if we apply KVL, V1 will be equal to I1 ZA plus I1 plus I2 into ZB. That is I1 ZA plus ZB plus I2 ZB. Okay. Similarly, we can apply KVL in loop number 2. V2 will come out to be I2 ZC I1 plus I2 ZB. That is I1 ZB plus I2 ZB plus ZC. Okay. Now if we express this in matrix terms, V1 V2 will be equal to ZA plus ZB 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 then ZB plus ZC I1 I2. Now for these parameters to be symmetrical, Z11 must be equal to Z22, that is ZA must be equal to ZC in order for these parameters to be symmetrical. That is, series arm impedance must be equal in order for the parameters to be symmetrical. For reciprocity, Z12 must be equal to Z21, and here as you can see Z12 equal to Z21, so it is reciprocal. That means these parameters are always reciprocal, but for them to be symmetrical, the series impedance must be same. Now if you want to express ZA, ZB and ZC in terms of Z parameters, then ZB is equal to Z12, which is also equal to Z21. ZA can be obtained as Z11 minus Z12. That is, if you subtract these two elements, you will get ZA. ZC can be obtained as Z22 minus Z21. That is, if you subtract these two elements. Similarly to the T network, we can define a pi network in which we define the Y parameters. Okay. Now, this is V1, this is V2. If we apply KCL at node 1, then incoming current is I1, outgoing will be V2 into YA plus V1 minus V2 into YB. That is V1 into YA, V1 YB plus YA minus V2 YB. Similarly, if we apply KCL at node 2, incoming current is I2, outgoing will be V2 YC, V2 minus V1 YB. That is minus YB, V1, YB plus YC, V2. So we can express these parameters in matrix form as I1, I2 equal to ya plus yb minus yb minus yb plus yc. As you can see, the off diagonal elements, that is y21 equal to y12, that is minus yb. So this is network is reciprocal. That means any pi network is always reciprocal. And if ya equal to yc, then the diagonal elements are also equal, then it becomes symmetrical. Okay. So like in the case of t parameter, for symmetry in case of y parameters, the shunt arms of the pi network must be equal. Now if you want to express ya, yb and yc in terms of y parameters, then how to write it? Yb will be equal to minus y12, which is equal to minus y21, and ya will be equal to sum of these two elements, y11 plus y12. Yc will be equal to sum of these two elements, that is y21 plus y22. So that is how we determine the y parameters for a pi network. Now, if you want to convert these parameters into one another, suppose we want to find out h equivalent of z parameters. Then, what is the relation in terms of h parameters? v1 is equal to h11, i1, h12, v2. I2 is equal to h21, i1, h22, v2. What about z parameters? v1 is equal to z11 i1, z12 i2, v2 equal to z21 i1 plus z22 i2. Now suppose I want to determine the relation between, or I want to express h parameters in terms of z parameters. Then if you observe this second equation, it is the relation between v2, i1 and i2. And if you see this equation, I2, I1 and V2, that means if we rearrange this equation, we can obtain the second equation of h parameters. So that means from this equation V2, I have to find out I2. So from this equation, I have to find out I2. I2 is equal to minus Z21 by Z22, I1 plus 1 by Z22, V2. That means H21 will be equal to minus Z21 by Z22 and H22 will be equal to 1 by Z22. Now, if we want to find out H11 and H12, then what we have to do is, if you see this equation, it is a relation between V1, I1 and V2. Here V1, I1 and I2 is there. So let us substitute I2 in terms of I1 and V2. So V1 is equal to Z11 I1 plus Z12. Now the equation for I2 is minus Z21 by Z22 I1 plus 1 by Z22 V2. So it will be equal to Z11 minus Z21 by Z22 Z12 I1 plus Z12 by Z22 V2. This will become Z11 Z22 minus Z21 Z12 by Z22 I1 Z12 by Z22 V2. This can also be written as V1 is equal to delta Z, that is the determinant of the Z matrix, by Z22 I1 plus Z12 by Z22 V2. Okay. So that will become H11 and this will become H12. Okay. So if I write down what are the four H parameters in terms of Z parameters, H11 becomes delta Z by Z22. H12 becomes Z12 by Z22. H21 becomes minus Z21 by Z22. H22 becomes 1 by Z22. Similarly, we can express H parameters in terms of Y parameters. So, the relation in terms of H parameters is V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. In terms of Y parameters, it is I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Now, if you see from the first equation, what we can write? This is a relation between I1, V1 and V2. And if you see, this is also a relation between I2, I1 and V2. From this equation, we have to determine V1 because V1 must be expressed in terms of I1 and V2. So, V1 from the first equation will be 1 upon Y11 I1 minus Y12 by Y11 V2. That means H11 will be equal to 1 by Y11 and H12 will be equal to minus Y12 by Y11. Okay. Now, if you want to determine the relation between I2, I1 and V2, we have to use this relation. But here V1 is also coming, whereas in this relation V1 must not be there. So, let us substitute the value of V1 in the second equation. Y21 1 by Y11 I1 Y12 by Y11 V2 plus Y22 V2. So, it will come out to be Y21 by Y11 I1 plus V2 Y22 minus Y12 Y21 by Y11, that is Y21 by Y11 I1. If you take the LCM, Y11 Y22 minus Y12 Y21 by Y11. Now, as you can see, this term is actually the determinant of the Y matrix. So, what I can say is I2 is Y21 by Y11 I1 minus plus delta Y by Y11 V2. So, if we compare the equations, we will get H11 is equal to 1 by Y11, H12 is minus Y12 by Y11, H21 is Y21 by Y11, H22 is delta Y by Y11. So, these are the 4 H parameters in terms of Y parameters. Next, let us derive the transmission parameters in terms of Z parameters. Now, the relation in terms of transmission parameters is V1 is equal to AV2 plus B minus I2 and I1 is equal to CV2 plus D minus I2. In terms of Z parameters, V1 is equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. Now, if we want to express V1 in terms of V2 and I2, we have to substitute I1 here because then V1 will be coming in terms of V2 and I2. So, I1 if we find out from second equation, it will be V2 by Z21 minus Z22 by Z21 I2. Substitute this in first equation, V1 will come out to be Z11 1 by Z21 V2 minus Z22 by Z21 I2 plus Z12 I2. That is, it will be Z11 by Z21 V2 then plus I2 Z12 minus Z11 Z22 over Z21. That is Z11 by Z21 V2 plus I2 Z12 Z21 minus Z11 Z22 by Z21. Now the numerator of this term is actually negative of the determinant of Z matrix. So it will be minus delta Z. So this can be written as V1 is equal to Z11 by Z21 V2 minus delta Z by Z21 I2. And since we determined I1 from the second equation, I1 was coming out to be 1 by Z21 V2 minus Z22 by Z21 I2. Okay. So from here I can see the ABCD parameters. A is actually equal to Z11 by Z21. B is equal to delta Z by Z21. C is equal to 1 by Z21. D is equal to minus Z22 by Z21. Okay, so that is how you can express, sorry, minus sign will not be here because we have to take minus I2. So this is how we can determine ABCD parameters in terms of Z parameters. Again, let us determine ABCD in terms of Y parameters. So the relation between voltage and current in terms of ABCD is V1 is equal to AV2 plus B minus I2. I1 equal to CV2 plus D minus I2. What about Y parameters? I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Now from the first equation I can determine, or from the second equation I can determine V1 in terms of I2 and V2. From the second equation V1 is equal to minus Y22 by Y21 V2 plus 1 by Y21 I2. So from this I can say A is equal to minus Y22 by Y21, okay, and B is equal to minus 1 by Y21. So now we know V, A and B. We need to find I1 in terms of V2 and I2. If you see this relation, I1 is in terms of V1 and V2, but we need in terms of V2 and I2. So we will substitute the value of V1. I1 is equal to Y11 minus Y22 by Y21 V2 plus 1 by Y21 I2 plus Y12 V2. So it will be minus Y11 Y22 by Y21 plus Y12 V2 plus Y11 by Y21 I2. Okay. If we take LCM, this will become Y12 Y21 minus Y11 Y12 by Y21 V2 plus Y11 by Y21 I2. Now if you see the first term, the numerator is negative of the determinant. So it will be I1 equal to minus delta Y by Y21 V2 plus Y11 by Y21 I2. So that is how we can find the ABCD parameters. Here A is actually minus Y22 by Y21, B 1 by Y21, B is minus 1 by Y21, minus delta Y by Y21, D minus Y11 by Y21. B and D are with negative sign because it should be minus I2 in the ABCD parameters. So this is how you can calculate one parameter in the form of other parameter. You just have to manipulate the equations. So let us summarize the interconversion of parameters. First, let us express Z parameters Z11, Z12, Z21, Z22. In terms of Y, it will be Y22 by delta Y. Delta Y is determinant of the Y matrix. And then Z12 minus Y12 by delta Y. Z21 minus Y21 by delta Y. Z22 Y11 by delta Y. Okay. In terms of H parameters, it is delta H by H22. It is H12 by H22. It is minus H21 by H22. Then 1 by H22. In terms of G parameters, it is 1 by G11 minus G12 by G11, then G21 by G11, then delta G by G11. Okay. In terms of transmission parameters, that is ABCD parameter, it is A by C, then delta T upon C. Delta T is AD minus BC, that is determinant of ABCD matrix. 1 by C, D by C. That is how you can determine Z parameters in terms of all other parameters. Similarly, we can derive Y parameters in terms of all other. So Y11, Y12, Y21, Y22. In terms of Z parameters, these will be Z22 by delta Z. This will be minus Z21 by delta Z, minus Z12 by delta Z, then Z11 by delta Z. In terms of H parameters, Y will be 1 by H11, then minus H12 by H11, then H21 by H11, then delta H upon H11. Delta H is determinant of the H matrix. In terms of G, it should be delta G by G22. This should be this should be plus G21. This should be plus G12 by G22. This should be minus G21 by G11. G21 by G22. This should be 1 by G22. Okay. Now if you see one similarity, here it was 1 by H11, it becomes 1 by G22, and Y11 becomes Y22. H12 becomes G12, H11 G22, minus sign is removed. H21 G21, H11 G22, minus sign is multiplied. And this term will come here, delta H will be replaced by delta G, H11 by G22. Same thing was happening in Z parameters. And the last, transmission parameters. Then transmission parameters for Y11 will be D by B. For Y12 minus delta T by B. Delta T is AD minus BC, determinant of ABCD matrix. Minus 1 by B. Then A by B. Next is your H parameters. H11, H12, H21, H22. In terms of Z, it will be delta Z by Z22. H12 will be Z12 by Z22. H21 will be minus Z21 by Z22. H22 will be 1 by Z22. In terms of Y parameters, this will be 1 by Y11. See, Z and Y are inverse of each other. So this will come here, but 22 will be replaced by 11. Then H12. H12 will be minus Y12 by Y11. This will be Y21 by Y11. So if you see, minus is multiplied here, and 22 is converted to 11. And then this will be delta Y by Y11. Delta Z by Z22 is converted to delta Y by Y11. Then The next will be in terms of G parameters. In terms of G parameters, it will be G22 by delta G. It will be minus G21 by delta G minus G12 by delta G, G11 by delta G. H and G can be directly written as they are inverse of each other. So what you have to do is, you have to take the inverse of this matrix. So you will replace the diagonal elements and take the negative of off diagonal elements and then divide by the determinant. So that is what I have done. G22 will come in the first place, divide by delta G. This will be actually minus G12 only, and this will be G21. Then minus G12 by delta G minus G21 by delta G, and then G11 by delta G. And last, H in terms of T, transmission parameters. In terms of transmission parameters, it will be B by D, then delta T by D, then minus 1 by D, then C by D. That is how you can determine H parameters in terms of all others. Next, we have to determine G parameters in terms of other parameters. That is G11, G12, G21, G22. In terms of other parameters, we have to determine first in terms of Z. In terms of Z, it will be 1 by Z11. G12 will be minus Z12 by Z11. Then G21 will be Z21 by Z11. G22 will be delta Z by Z11. In terms of Y, it will be Y12 by, in terms of Y, it will be, in terms of Y, delta Y by Y22. As you can see, this and this are replaced. Then minus Y12 by Y22. Okay. And we will multiply it by minus sign, so it will be plus. Then this term will be converted to minus Y21 by Y22. And this term will be converted to the first term, 1 by Y22. Okay. In terms of H, it is directly the inverse. So it will be H22 by delta H minus H12 by delta H minus H21 by delta H, then H11 by delta H. Okay. In terms of transmission parameters ABCD, it will be C by A minus delta T by A, 1 by A, then B by A. And the last ABCD parameters, in terms of Z, it will be Z11 by Z21, delta Z by Z21, then 1 by Z21, Z22 by Z21. In terms of Y, what you will do? You will take a negative sign and replace 1 by 22, Y22 by Y. Sorry, it will be first minus 1 by, it is first like minus Y22 by Y21. So what I have done is I have replaced Z11 by Y22 and multiplied by the minus sign. Next it will be minus 1 by Y21. Next minus delta Y by Y21. Next it will be minus Y11 by Y21. Okay. So this will be T parameters in terms of Y. In terms of H, it will be minus delta H by H21, minus H11 by H21, minus H22 by H21, then minus 1 by H21. And last, in terms of G, what you will do? It will be 1 by G21, then G22 by G21, then G11 by G21, then delta G by G21. As you can see similarity here also, this and this are replaced. And just delta G by delta H and with a minus sign. So this is how you interconvert the parameters into one another. In the next lecture, what we'll see is how you will determine the parameters of an overall network which consists of many subnetworks. Hi guys, up to now I was given a single two-port network and then I was dealing with its two-port parameters like the Z parameters, H parameter, Y, T parameters and the G parameters. But if you consider a complete system for an example, it may consist of many subsystems. That means a system may be divided into multiple subsystems like subsystem 1, subsystem 2, subsystem 3 and so on. Each of these subsystems can be modeled as a two-port network. That means a complex system may be considered as a interconnection of multiple two-port networks. Okay. So if you want to describe the entire system itself as a two-port network, then we have to determine the two-port parameters for this complex system in terms of the two-port networks of it, two-port parameters of its subsystems. Okay. So we have to derive two-port parameters. Now when multiple systems are connected with each other, the challenge lies in identifying the parameters which will give us a advantage. Like if the networks are connected in series, then their Z parameters can directly be added. So it is better if we deal in terms of Z parameters. If they are in parallel, then Y parameters are added. So it is better I deal in the Y parameters. So the only thing that we need to learn or identify is which parameters are advantageous to use in various scenarios. Okay. So there can be various connections like cascade, series, parallel and parallel series. In each we need to find the parameters that give us an advantage. Why these systems are cascaded? These systems are why these systems are interconnected? These systems are interconnected in order to realize a much bigger system. Like if we take an example of a car can have multiple subsystems like a steering wheel. The purpose of steering wheel is to give the direction. Then it has an accelerator. The purpose of accelerator is to increase the speed. Then it has a brake. The purpose of brake is to reduce the speed. Each of these subsystems can be modeled as a two-port network and they are all a part of a bigger system. That is why we need to know about the interconnection of the networks. Now first type of interconnection is the cascade connection. What is meant by cascade connection is the output of one subsystem acts as the input of the other subsystem. Okay. For example, what we can take is the output of one system being acting as the input of the other subsystem. Like what I can say is, suppose two bogies of the train are connected. Okay. The output of one system is the motion that applies a force to the other bogie behind it and then it also moves. So output of one system produces the force on the other which acts as the input. So that way if the output propagates to the multiple systems, then it is a cascaded system. Even in case of digital, take the case of shift register. In case of shift register, the output of one register acts or output of one flip-flop acts as the input of another flip-flop. That is a cascaded connection. So here, if I make use of the ABCD parameters, let us say first network has a parameter A1, B1, C1, D1. Second, A2, B2, C2, D2. Now here, if you express the relationship between the input and the output parameters of network 1, it will be V1, I1 will be equal to A1, B1, C1, D1, Vi. What about the other network? The input port parameters are Vi. Okay. And the output are V2, I2. The parameters will be A2, B2, C2, D2, V2, I2. As you can see here, I am not using a negative sign with the current because I am assuming that the current is outgoing. Okay. Even if you use a negative sign, then this current for another network will be outgoing. So we have to use the negative sign with input current also. So that is undesirable. It is better that you assume all the currents are outgoing. Otherwise, the sending end current or the input current of this will be in the opposite direction. Now, if you want the relation between the terminal parameters, that is V1 I1 and V2 I2, you have to substitute the value of Vi from the second matrix. So V1 I1 will be equal to A1 B1 C1 D1, then A2 B2 C2 and D2. Here it will be V2 I2. That is, when two networks are connected in cascade, their ABCD matrices or the transmission parameter matrices get multiplied. So what will be the resultant matrix? A1 A2 plus B1 C2, then A1 B2 plus B1 D2, then C1 A2 plus D1 C2 plus C1 B2 plus D1 D2. Okay. Now if we see that, suppose the networks were symmetrical. If networks are symmetrical, then A1 equal to D1, A2 equal to D2. Okay. That means A1 A2 plus B1 B2 B1 C2 is equal to D1 D2 plus B1 C2, which is still not equal to D1 D2 plus C1 B2. That is, the resultant A and the D parameters of the network are not equal, or we can say A equivalent is not equal to D equivalent. So it is asymmetrical, which means it is not necessary that a symmetrical network or cascading of two symmetrical networks will yield another symmetrical network. The network may be asymmetrical. Okay. So remember this concept. Whenever you connect two systems in cascade, you have to multiply their ABCD parameter. The next type of connection is called as series connection. In series connection, what happens is you have to connect network in such a manner that their currents must be same. As you can see here, I1 current is entering network N dash and I1 is leaving the network N double dash. So their currents are exactly same. In series, the currents must be same, but the voltages must get added. Now if currents are same, we have to choose a system in which we can keep the same current, or we can have currents as the independent variable. So if we choose the Z parameters, then let us say this has the parameters Z1, Z2, Z11, or we can say this has the parameters Z11, Z12, Z21, Z22. And the other one has Z11 dash, Z12 dash, Z21 dash, Z22 dash. Or we can mark these as dash and these as double dash in order to represent N dash and N double dash, so that the resultant can be modeled as Z11, Z12. Now, if we write the equation for first network, V1 dash I1 dash is equal to Z11 dash, Z12 dash, Z21 dash, Z22 dash, and I1, or we can say directly I1 and I2, because current is same for both the networks. What about other set of voltages? This is V2 dash. It will be V1 double dash, V2 double dash is equal to Z11 double dash, Z12 double dash, Z21 double dash, Z22 double dash, I1, I2. Now if you want to find V1, V1 is actually V1 dash plus V1 double dash, and V2 is actually V2 dash plus V2 double dash. Now if we add these two matrices, what I'll get, v1 dash plus v1 double dash will become v1. v2 dash plus v2 double dash will become v2. And their corresponding elements will also get added, z11 dash plus z11 double dash, z12 dash plus z12 double dash, z21 dash plus z21 double dash, z22 dash plus z22 double dash, I1 I2. So as you can see, when the networks are connected in series, you have to add their impedance parameters. Okay. So the impedance parameters give us an advantage when we are dealing with the series connection. Next type of connection is the parallel connection. In this, the current in both the networks is not identical, but their voltages are identical. So we have to use certain parameters which have the independent variable as voltage. So in this case, we will use the y parameter. So for the first network, what I can write? V1 I1 dash. Why I1 dash? Because current is not same. Will be equal to y11 dash, y12 dash, y21 dash, y22 dash. V2, sorry, this will be I1 dash, I2 dash. Here it will be V1, V2. For the second network, the currents will be I1 double dash, I2 double dash, and the parameters will be y11 double dash, y12 double dash, y21 double dash, y22 double dash, V1, V2. Now by KCL I can say I1 is equal to I1 dash plus I1 double dash. Similarly, I2 equal to I2 dash plus I2 double dash. That means if I add these two equations, their y parameters will get added up. I will get equation of something like this. I1 I2 is equal to y11 dash, y11 double dash, y12 dash, y12 double dash, y21 dash, y21 double dash, y22 dash, y22 double dash. Okay. So in parallel connection, the y parameters will get added up. Why parallel connection is used? Actually, it is mostly used in case of transmission lines. If you connect two lines in parallel, then the reliability of the system increases, so that even if one line breaks down, then the other line can be able to take the load. Next is our series parallel connection, and if you see here, at the input port both the networks are connected in series, at the output port both are in parallel. So when both are in series, their voltages will be added. That is why I will say V1 is equal to V1 dash plus V1 double dash. And at output we will have to add the currents due to parallel connection. So I2 will be I2 dash plus I2 double dash. So I'll have to use some parameters which makes use of V1 and I2, that is your H parameters. So now if I write the equation for the network number 1, V1 dash I2 dash is actually equal to H11 dash, H12 dash, H21 dash, H22 dash, and here we will have I1 and V2. And for the next network it will be V1 double dash, I2 double dash. Here we will have H11 double dash, H12 double dash, H21 double dash, H22 double dash, I1 V2. Now if we add these two equations, V1 double dash and V1 dash and V1 double dash will become V1, I2 dash and I2 double dash will become I2. And these parameters will get added up. H12 dash plus H12 double dash, H21 dash plus H21 double dash, H22 dash plus H22 double dash, I1, V2. So in a series parallel connection, our H parameters will get added up. Similarly, the other set is parallel series. So at the input, if you see, we have parallel connection. At the output, we have series. So at the input, I can write I1 is equal to I1 dash plus I1 double dash, and V2 equal to V2 dash plus V2 double dash. So we have to use parameters which uses I1 V2, that is your G parameter. So for the first network, I can say I1 dash V2 dash is equal to G11 dash, G12 dash, G21 dash, G22 dash. And here we will write V1, I2. For the next network, I1 double dash, V2 double dash, G11 double dash, G12 double dash, G21 double dash, G22 double dash, V1, I2. If we add these two equations, I1 dash and I1 double dash will give me I1, V2 dash and V2 double dash, V2. And these parameters will get added up, G11 dash plus G11 double dash, G12 dash plus G12 double dash, G21 dash plus G21 double dash, G22 dash plus G22 double dash, V1, I2. So in case of parallel series connection, your G parameters will get added. So you always have to remember which parameters to use in which type of connection. Let me show you how to identify this by means of some examples. In our first example, it is saying we have been given a general T network. Now these two T networks are connected in cascade. First of all, we need to find the transmission and the Z parameters. If you connect in cascade, then what will be the network? 2 ohm, 3 ohm, 4 ohm, then again 4 ohm, 2 ohm, 3 ohm, and again 4. Okay, that is 2, 3, 4, 2, 3, 4, like this. That means this network will become 2, 3, 4 and 2 in series will become 6, then 3, then 4. Now we know the Z parameters of a T network. So to make it a T network, let us convert this pi into or delta into star. Let me call it as Z1, Z2, Z3. So what will be Z1? Z1 will be 3 into 3 over 3 plus 3 plus 6. That is 6 by 12, 9 by 12, or we can say 3 by 4. What about Z2? 3 into 6 by 3 plus 3 plus 6. That is 18 by 12, or we can say 3 by 2. Z3, 3 into 6, 3 plus 3 plus 6, that is actually 3 by 2. Now this Z2 will be in series with 2 ohm, Z3 will be in series with 4 ohm. So what will be the resulting network? 2 plus Z2, 2 plus 3 by 2, that is 7 by 2. 4 plus Z3, that is 4 plus 3 by 2, it is 11 by 2. Then Z1, 3 by 4. Now what are the Z parameters? Z11. Z11 is actually sum of these two impedances, that is 7 by 2 plus 3 by 4, which is equal to 17 by 4. Okay. Z12 is actually 3 by 4. Z21 is same, 3 by 4. Z22 is again the sum, 11 by 2 plus 3 by 4, that is 25 by 4. So these will be the Z parameters of the cascade connection. Okay. Now we also have to determine the ABCD parameters of this network. We know the interconversion between the Z and the ABCD parameter. So if you want to derive the ABCD, you can derive from Z. That means what will be the value of A? It is actually Z11 by Z21. 17 by 4 divided by 3 by 4. It is 17 by 3. What about B? Delta Z by Z21. Delta Z is actually 17 by 4 into 25 by 4 minus 9 by 16. So how much will it be? 25 into 17 is how much? It is 425 by 16 minus 9 by 16, that is 416 by 16. Okay, that is 4104. That is how much? 26. So it will come out to be 26. Now, so B will come out to be delta Z by Z21, 26 by 3 by 4, that is 26 into 4, it is 104 by 3. What about C? C is 1 by Z21, that is 4 by 3. D, it is Z22 by Z21, that is 25 by 3. So these will be the Z parameters of your network. Okay. And now we have to connect this network in series. If you connect this network in series, then how you will make the connection? It is 2, then 3, then 4. In series, current must remain same. 3, then 2, then 4. So this network will be converted to 2, 6, 2. Or rather, what we can do, in series we know the Z parameters are added. So we must identify the Z parameters of this original network. Okay, that is 2, 4 and 3. If you identify the Z parameters, it will be 2 plus 3, 5, then 3, then 3, then 4 plus 3, 7. So Z parameters of equivalent will be addition of the Z parameters of two networks. Since both the networks are identical, the Z parameters are also identical. So addition will give me twice the original value. 10, 6, 6, 14. From this I can determine ABCD parameter. A will be Z11 by Z21, that is 10 by 6 or 5 by 3. B is delta Z by Z21. Delta Z is 140 minus 36. 140 minus 36 will be how much? 104 by 6, that is 52 by 3. C will be 1 by Z21, that is 1 by 6. D, Z22 by Z21, that is 4 by 6, or we can say 2 by 3. So these will be my ABCD parameters. In the next problem, it is asking us the Y parameters of the two-port network. We have been given Y parameters of one network and we have connected a resistance in parallel. Now if you consider this resistance as another two-port network which is connected between V1 and V2. Here current is I1, I2 and it is 1. Since both are in parallel, we need to determine Y parameters of this network. I can say I1 is equal to V1 minus V2 by 1, that is equal to V1 minus V2. And from the figure I can say I2 equal to minus I1, that is V2 minus V1. So what are the Y parameters of this one? It is 1, minus 1, then minus 1, 1. Now equivalent Y parameter will be the sum of both Y parameters as both are in parallel. 4 plus 1, 5. 2 minus 1, 1. 1 minus 1, 0. Sorry, 1 minus 1 will be 2. 1 minus minus 1. 1 minus 1 will be 0. Actually, we are adding these two. 1 plus 1 will be 2. So these will be the equivalent parameters of the resultant network. So let me summarize what we covered in this lecture. We saw the interconnection. So first I explained why we interconnect the network in order to realize a more complex network. So we first saw cascade connection. in which we will multiply T dash and T double dash. So the transmission parameters matrices are multiplied. Then we saw series. In series we add the Z parameters. Then parallel. In parallel we add the Y parameters. Then series parallel. Here we make use of the H parameters. Then parallel series. Here we make use of the G parameters. So just remember this thing and you can solve any problem based on interconnection of networks. This is important from the two-port networks. So this is all about your interconnection of the networks and it is all from the two-port networks.